So let's look at another counting problem. So let's say we're talking about cards again, and we're going to talk about something related to the game of poker. Is played with an ordinary deck of 52 cards, various 5-card holdings are given special names. So in the game, people have 5-card hands, and if they have a special type of hand, it's given a special name. So for example, the one we're going to talk about, 2 pairs. So we would say someone has 2 pairs if they have 2 cards of one denomination, 2 cards of a second denomination, and a 5th card of a third denomination. So for example, if they had 2 2s and they had 2 3s and then a 4, that would be an example of a hand that would be called 2 pairs. So now I want to know how many 5-card poker hands contain 2 pairs. So we're going to break this process down into steps, kind of like before with the committee, how we had step 1 pick the men, step 2 pick the women. So step 1, you're going to choose the denominations for the pairs. So what are my pairs made up of? So like in the example I did before, verbally I said we had a pair of 2s and a pair of 3s. So first you're going to pick out those denominations. Or do I have a pair of jacks and a pair of queens? Then step 2, for the smaller denomination, you're going to choose 2 cards from the smaller denomination. So if I have 2 2s, you're going to pick those 2 2s. Step 3 looks similar to step 2. You're going to choose the 2 cards from the larger denomination. So if I have 2 3s, like I'm going to select those next. And finally, step 4 is you have an extra card that's not involved in the pairs. So you're going to choose the one remaining card. And here, because we're breaking it down into these independent steps, you're going to use the product rule. So let's start with step 1. So choose the denominations for the pairs. So there are 2 pairs, and how many possible denominations? Well, there's 2 3s, 4s, 5, 6, 7, 8, 9, 10, jack, queen, king, ace. There's 13. So 13, choose 2. And then you're going to multiply that. So for the first smaller denomination, there are 4 different possible cards. Like if I had twos as my smaller denomination, there's a two of hearts, diamonds, spades, and clubs. So out of those, I'm going to choose two of those. And the same thing for the larger denomination. There are 4 cards of that denomination. There are 4 threes, and you're going to select 2 of them. And then I have 1 card to pick, but how many options do I have for that remaining card? I can't pick any of the denominations that were already chosen, so I can't. There are 8 cards that I cannot pick anymore. So 52 minus 8 would be 44. So there's 44 possible cards, and I need to choose one of them. So you're going to calculate these out, and you'll multiply them to get 123,552. So that's how many 5-card poker hands contain 2 pairs. And maybe if we were playing poker, we'd like to know if a 5-card hand is dealt from an ordinary deck of cards. What is the probability that the hand contains 2 pairs? Well, we need to find the total number of all 5-card hands. So there's 52 cards, and we're going to select 5 of them. So this is 2,598,960. So remember the way probability works. It's a fraction where you put the total number of possible counts in the denominator, and in the top, for your specific event, my event here is the hand contains 2 pairs. We counted that in part A, 123,552. So this would be the probability. If you converted it into a percentage, it's approximately 4.75%. So it's not really that likely that if you had a random hand, it would contain 2 pairs.